Okay, so for number 6, we're trying to figure out end behavior. So let me write that function down here one more time. So 6, we've got y equals 1 over 2 to the x minus 2, all plus 3. And so one of the things we want to figure out is what happens as x goes to negative infinity, then y goes to something. Okay, so for that, let's try an example. Let's say, let's pick a really negative number. So, example, let x equal negative 10,000, let's say. Okay, then y would be 1/2 to the negative 10,000 minus 2 more, and then plus 3. So that would turn into 1 over 2 to the negative 10,002 plus 3. And then to get rid of that negative, we flip the inside. So that really turns into 2 over 1 to the 10,002 plus 3. Well, 2 to the 10,000 is some massive number. And then we add 3, so it still stays pretty big. Basically, that thing, the more zeros I add onto here, the more I have to add onto there, the more they get crammed in there, the more they get crammed in there. That number just gets bigger and bigger and bigger. So this thing is going to go to positive infinity here. Well, let's look at what happens as x goes to positive infinity. Okay, so let me move this stuff. Actually, I'll shrink that down a little bit. Okay, so for this one, I'll use a different color. So for example, let's let x be like 10,000. So positive, a big positive number. Let x equal 10,000. Okay, so then y is going to be 1/2 to the 10,000 minus 2, and then plus 3. So that's going to be 1/2 to the 9,998 plus 3. Well, if you do 1/2 multiplied by another half, multiplied by another half, multiplied by another half, you did it 9,998 times. This thing is going to be pretty small. It's going to be almost 0, and then plus 3. So this whole thing is just getting closer and closer to just 3 the bigger x gets. So y turns into about 3. You can also think of it like this. If you just look at this part, when x gets really, really big, that 1/2 to the thing turns into 0. And then you've got plus 3. So it moves up 3. Okay. So then let's look at 7. 7, we're trying to graph the thing from 6. Okay, so let me recopy that one down here. So 7, we're trying to graph y equals 1/2 to the x minus 2 plus 3. So the parent function there is going to be y equals 1/2 to the x. Okay? Well, 1/2 to the x, here, let's make a chart. X, y, -2, -1, 0, 1, 2. And then we'll also do asymptote, domain, and range. Now 1/2 to the x, that's a decay because it's less than 1. It's coming downwards like this. Right? Well, if I plug in -2, then what I'm really doing is 1/2 to the -2, which is the same thing as 2 over 1 squared. So that's going to be 4. So I get 4 here. If I do 1/2 to the -1, that's the same thing as 2 over 1 to the first, positive 1. So that's 2. 1/2 to the 0 is 1. 1/2 to the first is 1/2, and 1/2 squared is 1/4. Okay, so there's what we've got for our chart. The asymptote for any parent function for an exponential is y equals 0. The domain's always all real numbers, and the range is always positive values. Okay, so now we've got that chart. To get to the next chart, there's no stretching factor. There's no number in front here. That's just a 1, basically. So we can skip what would normally be the middle chart and go straight to a final chart. And the -2 means I'm going 2 to the right, and the plus 3 means I'm going 3 up. And so 2 to the right, I'm going to add 2 to all my x's. So that's going to be 0, 1, 2, 3, 4. And then I have to add 3 to all my y's, so I get 7, 5, 4, 3.5, 3 1/4. And if I'm adding 3 to all my y's, I get a new asymptote. It's going to be, instead of y equals 0, I've moved 3 up, y equals 3. My range, if I add 3 to the y's, it's now y is greater than 3. The domain, I add 2 to all my x's, but my x's are everything. So I'm still going to get everything. So this is what we need to graph the thing. So let's make a chart, or a graph. Everything's positive in this picture, in this chart. Let's see, I'll go up to 7 on the x. 0, 1, 2, 3, 4, 5, 6, 7. And then, oh, sorry, no, I don't actually have to go that high. I only have to go up to 4 on the x's. So 1, 2, 3, 4. And then up to 7 on the y's. 1, 2, 3, 4, 5, 6, 7. And I've got an asymptote at 3. Y equals 3. I've got the point 0, 7. 1, 2, 3, 4, 5, 6, 7. Then 1, 5. 2, 4. 3, 3.5. 4, 3 1/4. And you can kind of tell this thing looks like, looks like this right there. Like that. So it's exponential decay. Here are 5 points. Here's our asymptote, domain, and range. Okay, hope that helps a little bit.